What you're looking at here is we have an elevator in Duluth, Minnesota, has 1,500 silos that need to be managed as the grain goes through that silo. On every square is a whole bunch of information that's written in chalk by the operator. When the screen gets full, he flips it up and goes to the next one, and so on and so on. And when you look at that chalkboard, it has multiple sources of information. That 1,110 is actually the bin number. Like I said, we had 1,500 bins. Milford and Rostern are actually grain elevators in Saskatchewan. So that tells you about where this grain was sourced from. SK15 is the rail car number that it came in on. 12-8-15 is the first date that we actually filled that bin. 1XOHO is actually the grade quality of the oat grain. 41.7 to 97.5 are actually protein numbers of the grain. So that little chalkboard's full of information. Oh, by the way, the bin's full. And we got 1,500 screens like that. When you take those screens on chalk, the next leg down the line is our mill that actually takes this grain and actually mills it into flour. They don't see that chalkboard. So now they've got grain coming to them of unknown quality that they put in their elevators. And in this particular facility, there's over 50 elevators. And guess what happens when you don't know the quality of it? You don't know how to use it. You don't know what recipe to use to actually mill this stuff. Guess what happens with your energy costs? Goes up. Because I don't know how to make this stuff. I don't know how to convert this product into good product. I'm guessing on my recipes. I'm guessing on this stuff. And you take a look at this, and just look at the black circles, and look at the red circles. Between black and red, that's the percentage of the factory that is not usable. It's sitting in an idle state. And I don't know how many of you guys have gone out and seen the size of elevators or silos. These are silos that are 100 feet tall, 16-foot diameters. What happens if you fill it up and you have stuff that's unusable? How do you get it out of there? How long does it take to get out of there? Where does it go? Who takes it away? All that kind of stuff. All that is waste. Just waste, waste, waste. So what we did was we took a solution approach under the SMLC banner. And if you look on the far right-hand side, this rings to what Jim Davis just said. Sources, or what are your data sources? Contextualization, and then applications that we had to build. And the big two items that really had to get redone here was this concept of that is brand new here, I should say, is contextualization and applications. And we did this as a trifecta of General Mills, ThinkIQ. Doug and Niels are here from ThinkIQ right in the front. And then Savagent and Mark Besser's over on that table. So you can feel free to talk to any of those guys about the technology behind all this. But we had to figure out a way to connect people, chalkboards, bins, sensors, receiving information, typically SAP kinds of information, rail car systems in transportation knowledge, put it into a data model that didn't exist, contextualize it because all the different sources you have different time dimensions, and then do something with it. So what are we trying to do? We're trying to manage those bins so we don't have blacks and reds. We're trying to get genealogy so we can ensure from field to fork that the consumer is getting pure product right all the time. We have a concept in the food industry called positive release, and that is you cannot release your product to the next channel down until everything about what you make is right. So if you're not sure your stuff is right, you hold on to a lot of inventory. When you hold on to inventory, you spend money. So the only way to move the flow of ingredients from ingredients to finished product to the consumer is to do it right the first time and to do it fast. Otherwise, you're going to be bound up in inventory. And then we had to do basic grading and sizing. And I was sharing this a little bit with Craig earlier this morning. And you look at this, and this is an oil and gas problem. Oh, no, wait a minute. This is a mining problem. Oh, wait a minute. This is another grain problem. this concept of managing flow, of understanding waste, of understanding the information that is going through the transformation process, the energy that's consumed and wasted in that process is universal to manufacturing. Anyone that makes stuff does stuff like this, because hardly anybody takes the raw material and that is the end product. Some transformation has to happen. Here's what our new bin board looks like. Here's our modern chalkboard. This is coming out of the cloud, based on a semantic web model, web technology. This is now showing you the bins, how full they are, what status they are, etc. This one here with all the serration is actually telling you what's in the bin, what supplier made what, how many pounds are in it. I can actually drill into it. And when I drill into any one of those, I can click on it. I get a Sankey diagram that shows the flow of how it got there. That bin on the you go on this case, you would go from right to left. You'd say that bin came from 4 streams. Oh, let's drill in and find out what one of those streams came from, and then you find its path all the way back. This is true genealogy and traceability. All of this is done with a brand new way of looking at data, a totally different way of looking at data. Positive release, same thing. Take this information. I can't release shipment. Make this stuff available. Figure out what it is. Then go and release it to the supplier. We actually tell the transportation company when to come to our dock, which place to go. Not sit there in demerge and have their engine running while we're waiting for them to show up. Because we're managing the quality and the information flow of everything that we make, we can be precise about when they should show up. At the end of the day, we end up with improved safety. We have demand-driven supply chains. This little example that I went through, we're going to save about $20 million in ingredients, and we're going to save about $1 million in energy. So we're going to blow 6 months. So we're going to blow our numbers out of the water when we talk about the goal of 10 or 15 or 20% energy savings by doing the right thing for productivity. And that's the cool part. It's kind of like the sustainability story. Do you want to do sustainability for sustainability, or do you want to do it for good business? Because they actually go hand in hand. So this is why it's an easy sell in my supply chain network to talk about smart manufacturing driving productivity, because I get multiple levers that are beneficial. I get an energy lever. I get a productivity and a cost per case lever. I get an improved safety record. I get improved quality record. I mean, it's like telling the story of continuous improvement. It's multiple levers, multiple facets. That's why this stuff is so important. And the thing that makes this tick, and in this particular example, the new technology or the new approach that kind of freed us up was not about connecting data sources. That's now common technology. A lot of people can do that. What freed it up for us was what ThinkIQ is doing with their data modeling capability and using semantic technology, connecting with what Savagen's doing with workflow as a service. And it's all these elements that Jim Davis talked about around the topic of a platform and plugging in these core capabilities that allows us to do the kinds of things that we're doing.